So we are going to take a look at factoring by grouping as it relates to a difference of squares. So before we get started, we should sort of talk about some basic facts. For instance, what is the square root of 4 squared? 4. All right, just shout out the answers here. That'd be fine. So this is 4. What is the square root of 9 squared? 9. What is the square root of, oh, I don't know, 16x squared squared? All right, last one. What is the square root of x minus 4 squared? X minus 4. Okay, so as long as we understand that, we are in good shape. All right, so here we go. So I'm looking at this term, or this problem right here, and it looks really, really funky, doesn't it? But I notice that this is a perfect square. Because how do I know it's a perfect square? I know it's a perfect square because it is squared. Simple. I notice that this term right here is a perfect square also. And I am subtracting the two. This is a difference of squares because I have two perfect squares that I am finding the difference of. I am subtracting them. So I know that I'm going to have two pairs of parentheses. Now I'm using brackets here, which is just another way of writing a parenthesis. There's no difference here. And what I'm going to do here is I know that I'm going to have one term that has a plus symbol inside of it and one that has a negative because all differences of squares are factored in that manner, and you know that at this point. And so all I need to do is take the square root of this term as well as the square root of my second term. What is the square root of the binomial a minus b squared? A minus b. And so that's going to go in both of these, right? What is the square root of 4c squared? 2c. Oh, okay. I do not need these parentheses here because I'm not multiplying it by anything. So I'm just left with a minus b plus 2c times a minus b minus 2c. And that's it. That is the end of it.
Wait.
Yes?
Could you keep the outside parentheses, the box?
You know, so the question is, can I keep the answer like this? Here's the thing. This is technically not in simplest form because you do have these two sets of parentheses. And you know, I can give you another example. I'll give you another example right now that would show you why you need to reconcile the parentheses, okay? So to answer your question, I'm actually going to take this problem, but I'm going to flip it. So I'm going to go 25 minus 9 times m plus n squared. So this is the problem I'm going to work on. All right? The first thing I have to ask myself is, what type of quadratic is this? I have a perfect square here, and I have, oh look, I have perfect squares here, and I am subtracting them. What do I have? I have a difference of squares. So the same process will continue. We're just following the pattern that we find. What is the square root of 25? 5. To get a negative here, I have to have a plus and a minus. What is the square root of 9m plus n squared? 3 times m plus n. And that's not too bad, is it? Well, I can't leave this problem like this because it is not in simplest form. Why isn't it in simplest form? Well, I can distribute this 3. So really I have 5 plus 3m plus 3n, and that's being multiplied by 5 minus 3m minus 3n. So that's why I have to deal with the parentheses, to show that everything has been done that I can do. So these problems aren't really overly challenging, but they look scary. Terrifying, really, if we're being honest. But this process is not a difficult one to follow.